Alright, so the next scenario is Grom, where you had to pick one scoop of ice cream, and you also need syrup with the ice cream. However, the flavor of the syrup has to be different from the scoop of your ice cream. So for A, to have a different combination than the person before you that ordered, it's really easy, but you just need to keep in mind that the syrup and ice cream combinations has to be different. So we can say that vanilla syrup with chocolate ice cream, strawberry syrup with pistachio ice cream, and pistachio syrup with vanilla ice cream. Sounds really good. All right, so for the second question, or for part B, how many combinations can we have with the given scenario in this given situation? So the answer here is 12. And the reason this is because, well, first of all, the combinations we cannot have are, let's think about it. So chocolate and chocolate, vanilla and vanilla, strawberry and strawberry, and pistachio, ice cream and syrup, respectively. So if you look at the table next to me, you can see that there's a couple of diagonal squares that are blank. Those blank squares represent the combinations that are not that do not meet the requirements or the situations, right? So those are the ones that are like the vanilla ice cream and the vanilla syrup ones. So you can see that the boxes that are filled from the table are in total 12. Or we can also think of them as having, for one ice cream flavor, there's 3 different syrup combinations because we are subtracting one of the syrup combinations, the syrup flavor, which is, for example, vanilla and vanilla, right? We can have that. For the third part, or part C, it's asking what if we add our 5th flavor. So again, let's use blueberry as an example, all right? So it's the same thing, right? We can't have blueberry and blueberry, right? So if you look at the table next to me, you can also again see that the diagonal there are blank squares or blank boxes, right? Those again represent the combinations that do not meet the requirements of the scenario. So those are again the same flavors. So if you count the boxes next to me from the table, there's 20 different combinations you can see. We can also say that from the 5 flavors of ice cream, for each of them, there's only 4 different syrup combinations that you can do. So 5 times 4 in this case is 20. All right, so how to represent this with the easier way, with visually. Again, we're gonna use tree diagrams, right? So if you look next to me, the tree diagram, you can see that there's 4 different ice cream flavors. However, there's only 3 syrup combinations because we are getting rid of the syrup flavor that is the exact same as the ice cream flavor. So there's 3 of them, right? So 4 times 3 is 12. There's 12 different combinations. And this is pretty much the same for 5 ice cream flavors when we add another flavor and a syrup, right? So there's 5 different ice cream flavors. However, there's only 4 syrup flavors because, again, we are removing the syrup flavor that is the same as the ice cream flavor. So you can see that there's 4 branches that branches out from the ice cream flavors. So there's 4 of them, right? So 5 times 4 is 20. So answer for a second part, or part C, is 20 combinations.